Yo, so we got animation and 2D animation, ... So, cell animation, what is it? Well, cell animation, first used in 1914, was an early animation form which involved drawing every frame on sheets of transparent plastic. The word cell is short for celluloid, which is a transparent plastic, and layers of celluloids were used to animate objects and characters separately to add depth to the animation. And this layering technique was an important technique that was used and is still used in today's 2D animation. Oh, animation, there we go.
Stop motion. Stop motion is a form of animation that is captured one frame at a time, with physical objects that are moved between frames. An example of this is Coraline, a movie that took 20 months to shoot. Isn't that absolutely shocking? Claymation. Claymation, or clay animation, is a form of stop-motion animation that uses clay figures and objects. Traditional claymation involves the manipulation of physical clay figures and objects and taking photos for each frame. Wires and armatures in the body of clay figures make movement possible. After taking a photo/frame, animators manually go through the process of moving, adjusting the position and rotation of objects, characters, limbs, etc. Claymation requires lots of patience, and usually it requires a team. Animators also have to pay attention to finger marks and other dirt marks in the figurines, as they may be hard to spot during production, but really stand out during post-production.
Oh, path animation. So, path animation is often used when an object needs to move along a specific path. The computer generates frames through algorithms. This means the animator doesn't need to draw every frame, which can save loads of time for the animator. However, the disadvantages of path animation is that there is less control over the animation, therefore a lack of detail in the movements. Morphing and tweening are two important processes that involve generating frames in between keyframes to make an animation look more smooth. Morphing is more of a digital process that involves computer-generated frames, to make an image transform to another through warping and cross-dissolving, etc. Tweening, on the other hand, can be hand-drawn or computer-generated. Tweening refers to the key technique used in all animation. It is a key process of adding frames in between two keyframes or poses. Adding those intermediate frames will make the animation come to life.
Behavior animation. It is a type of computer animation that involves automating a character or object. Behavior animation allows the character to determine its own actions to a certain extent. The actions of the character are controlled by computer-generated algorithms. Behavior animation is usually used in animating the synchronized motions of flocks, schools, herds, or crows in games, animated films, etc. This can save time, as the animator would not have to animate every single entity in a flying flock of birds, but still have a variety and diverse range of movements for each bird, for example.
Oh, frame rates. The frequency of which still images are displayed to create the illusion of motion. The standard frame rate in animation is 24 frames per second. This means that there are 24 frames/images being shown for every 1 second. Animators often work in twos, meaning one drawing for every 2 frames. The reason why animators work in twos is to reduce the amount of work and time put into the animation.
Transitions. Transitions alter the appearance and behavior of an element when a state change occurs. Transitions can use any kind of visual effect and motion technique such as face, slide, fold, scale, or mask transition. Transitions are used in programs, web pages, animations, videos. The purpose of transitions is changing from one scene / object / state to another smooth and less jarring state, and it helps to provide visual continuity.
We got loops. So taking or creating a short animation and continuously repeating it through the use of software and programs. This technique is useful in 2D animation when animating a movement that occurs repeatedly, such as the rotary blades of a helicopter. We can use looping to repeatedly play an entire short animation. Where am I? Or we can use loops to repeat a movement made by an individual object or symbol in an animation. For example, we can loop a fan moving in a scene in the background, or we can loop a waving hand of a character. Looping an animation can save an animator time by reducing the amount of frames needed for the animation.
Oh, shoot. So we have 3D animation, and that is the process of generating 3D moving images in digital environments through 3D software. And we manipulate these 3D objects or surfaces and are exported as picture sequences, making the illusion of an animation or a movement. So first up, we have rendering. 3D rendering is the production of image or subject based on 3D data put into an image. And it is the last step of computing color values of every single pixel in the image. It is also used when all other components of 3D animation is finished. And here are some examples before and after. Yeah, cool. So next we have wireframe. Wireframe is a 3D model based on the vertices and lines, and they provide the most basic representation of a 3D scene or object. These are used as a starting point in 3D modeling, and they create a frame for the 3D structure. Speaking of modeling, that's up next, and it is a technique in 3D composition graphics, where it allows for production of three-dimensional representative of any object or surface. The user is able to use special software to manipulate points in a virtual space called vertices to form a mesh or collection of vertices to form an object. Film models use these for an array of things. The 3D modeling can be used for architecture, animation, video games, engineering, advertising, films, and illustrations. Next, we have a motion capture, and it refers to the capturing actions of human actors, then using that information to digitally create character models for 3D animation. And there are many types of motion capture systems out there. There are optical and non-optical types, where optical is where they track the motion of reflective markers or pulsed LEDs, and non-optical uses no reflective markers. Markers are basically markers put on one's body. And then there's passive and active types. And active types use LED markers connected by wires to the motion capture suit, while the passive doesn't. Without markers is where, well, you don't use any markers, and it uses special software to track the subject's movement. We then have non-optical, and there are types of those. There are inertial, which is a technique that does not require any cameras except as a localization tool. Magnetic, which uses sensors on bodies, and these sensors are cabled to an electronic control unit. And there's electromagnetic motion capture, which is one of the more technical types of motion capture, relying on transmitters and receivers to track movement.
Morphing. Morphing is a special effect in motion pictures and animations that changes or morphs one image or shape into another through a seamless transition. In other words, it is the process where an animated object changes from one form to another over time, where there is a gradual transformation over the duration of the morph, an alteration to the points of an object, resulting in the object being transformed. This ability to morph models in a 3D environment is needed for an expert animator. Warping. Warping is the smooth distortion of an image and/or color while keeping the intact shape of the subject. A warping motion is created by overlapping frames while distorting the curves of the image/shape. It is the process of digitally manipulating an image such that any shapes portrayed in the image have been significantly distorted. Warping may be used for correcting image distortion as well as for creative purposes, such as morphing.
Okay, so virtual reality is a computer-generated experience taking place within a simulated 3D image or environment. It creates a seemingly real and physical user experience, immersing the user into the experience by looking at 3D animations of an environment or 360-degree images or videos from a new perspective within. This is done by incorporating elements of auditory, visual, and sensory feedback to make it seem so surreal. There are a few essential components that help create the overall experience of virtual reality: VR headsets, joysticks, controllers, head tracking, eye tracking, and motion tracking, as seen here. VR simulators use 3D objects and environments to create an immersive and engaging experience in a virtual simulated world. The main equipment needed for this are headsets with head tracking sensors and special controllers such as joysticks and gloves, which are used to interact and control the environment and objects. This creates an interactive digital immersion of a virtual reality environment or situation for the user to experience and interact with and control the simulation. This has been adapted in various industry sectors, which help aid in their work and development. For the education or training of staff, it is used to develop skills while minimizing levels of risk and injuries. Training surgeons use VR simulators to practice their technical skills, simulating the experience of treating patients virtually without any risk to an actual patient. Training staff use virtual reality simulators to train their staff in using machinery without the cost of injury and equipment damages. In the healthcare sector, VR simulators have recently been introduced for cognitive behavioral therapy, which help treat patients with social anxiety and phobia. The patients are placed in a controlled environment where doctors are exposed to patients in simulations to help them cope with the situation. Motion simulators create a total immersive experience where users are exposed to a range of physical motions reacting accordingly to the visuals, such as its use in flight and driving simulations. This minimizes any risk of injury and damage expenses while still developing their technical skills in applied scenarios. VR walkthroughs are a tour or demonstration of an area, which VR is incorporated to enhance this experience by creating a more immersive experience of the environment in first person. VR walkthroughs are created using 360-degree images combined to create virtual environments and 3D animations to create a prototype model of an environment or building. This has been recently introduced in architectural projects, creating an encompassing visual model. It is used to test cases in project development for easier collaborations with clients. It allows them to present building projects in VR walkthroughs to clients, providing a better understanding of the design in a first-person point of view, rather than just a small prototype model sitting on a table, and allows them to be more emotionally involved. By testing designs in 3D walkthroughs, it allows for further corrections to be made before being built. VR navigable scenes are 360-degree views of a scene which users can look through, showcasing a wider view of an image or video for a more immersive experience. However, this is usually non-interactive. It can be viewed through a headset with head tracking sensors to view the scene, or a display where the view can be moved around with touch controls or a mouse. VR navigable scenes have been used in advertising and marketing campaigns to promote a business or product. This allows for users to be highly and emotionally engaged. This has been used in YouTube advertisements such as Hyundai's Ioniq 360-degree VR ad promoting their new car model Ioniq, and Xfinity's 360-degree NASCAR VR experience promoting their digital cable TV service and the availability of a NASCAR channel. Yeah, that's it.